Okay, here we are looking at our logger and sensors. I've done some things here to help me simplify my setup in the field later on. Regarding the logger, I've actually mounted my PVC brackets onto the back of the logger using the flathead slotted screws. Okay, I've used very few tools to do this so far. Right now all I have is a Phillips head screwdriver, a regular screwdriver, and a pair of diagonal cutters here. Okay, so as I said before, I've got these connected here, the plates, the mounting plates. I've thrown the U-bolts on there, once again just trying to simplify the assembly so I have fewer loose pieces laying around. You can see these are the batteries that come with the unit. They get installed into here, go underneath this cover plate. This is the actual communication port that you would hook up to your computer to actually talk to the logger. And then here are the actual ports for the sensors. That's where we'll be plugging all of those into. The actual sensors, okay. Here we have temperature sensor. Okay, you can see the actual thermistor tip here protected by the stainless steel housing. And to actually hook this up at this time to the logger, all we simply need to do is plug it in like that, as we'll do with all the rest of the sensors. Then once we've got it hooked up to our computer and running, we can actually do something to the tip of this particular sensor. This is a temperature sensor, so we can simply put our finger on it and we can actually watch the reading of the sensor go up on our computer to make sure that it is in fact working. As well, you'll see that the sensor should be reading somewhere around room temperature. Here we have our wind speed and direction sensor. Once again, it's a very simple plug-in to the logger. And once you've got that hooked up to the computer, you can again give it a spin to make sure that you're getting some kind of reading from the thing. And as well, you can change the direction. I set up my wind speed and direction sensor here into a piece of wood. This thing's designed to withstand a lot of high force wind and the elements and whatnot. But should you lie it down on a table like this, it's very easy to break these things. So just a couple minutes spent making a little stand is probably worthwhile so it doesn't get damaged in the lab. The rain sensor. Okay, this is a tipping bucket rain gauge. I've unpacked it from its box, obviously. Something you need to note is that there is an elastic band holding the tipping bucket in place so that it doesn't tip during shipment or get damaged. You want to make sure that you remove that rubber band prior to deployment. And depending on your trip out to the field from the lab, you may want to reinstall that rubber band to protect the mechanism during your shipment. So once again, very simply, you undo the cable, you plug it in. Once you see it up on the screen of your computer, you can tip the bucket a few times to see that you've actually gotten counts. Something I want to mention about the packaging for this stuff. I didn't unpack it for you so that you could see it, but some things you should really save the packaging for, such as the wind speed and direction sensor and the tipping bucket rain gauge. Once again, this is a very delicate unit, and we have some very specialized packing for it so that it doesn't get damaged in shipment. And I think you want to reuse that once you're taking this outside into the field. The same with the tipping bucket. It's more of a simple box, but it's good to protect it while you're moving it. Here we have our soil moisture probe. And once again, you want to plug it in and see that you get a reading on the computer. If you really wanted to ensure that it was working correctly, you could have a little pot filled with some potting soil or whatnot. Maybe grab a plant from the receptionist's area, stick it in there, and then water the thing and see if the reading actually changes. We have our PAR sensor. You want to plug that in, make sure that you're getting some kind of reading. And here we have solar radiation that has a relative humidity sensor in it that actually records temperature as well. There was a little bit of assembly involved on this unit. You can see the two brass thumb nuts underneath here, and that the cable has been attached to the bracket using a couple of tie wraps. Once again, I advocate doing that in the laboratory. Just the less pieces you have laying around, the less likely you are to lose something. If you drop one of these nuts outside, it'd be easy to step on it, mash it into the dirt, and never see it again. Whereas if it's all put together here in the lab, it's hard to lose those pieces once you get outside.